Spice Math. That's right. You add it up, multiply it, man. Spice Math. Okay. A couple things we're gonna learn today. Spice Math. All right. Take some time, educate yourself. Spice Math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Doughton.
Hi, I'm Aaron Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Doughton.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hey, what's up, mathematicians? Welcome to Spice Math. In today's session, we'll be talking about solving the linear equation. This is part one of a series of videos talking about solving linear equations. So now let's talk about our objectives for today. By the end of this video, you should be able to, 1, explain what is required when an equation must be solved. 2, appreciate the equilibrium nature of a linear equation. Number 3, group terms and constants on the same side by moving them around. Number 4, solve linear equations by adding and subtracting a constant from each side of the equation. And number 5, we need to be able to explain the term solving. So now let's talk about what you're going to need to go on this math journey with me today. The first thing you'll need is your pen and a pencil. You'll also need a notebook, and as well as hard paper and a pair of scissors. So from our last session, there are some things that I want you to keep in mind coming into this session. The first thing I want you to remember is that an equation is a statement that includes an equal sign. The second thing I want you to remember is that equations are made up of constants and unknowns. The unknowns are typically letters, while the constants are typically numbers. I also want you to remember that the equation consists of two sides, the left-hand side and the right-hand side, and these sides are separated by the equal sign. So now that we've gone through the recap, let's get into solving linear equations. So to get us warmed up, to get us hot for the math, let's move around some parts of our equation. What I'm going to do is I'm going to write an equation on the board, and you'll also write it on a piece of paper, and we'll take it from there. Okay, so now that we have our hard paper, let's copy the equation that was written on the board onto our paper, and we'll take it from there. Plus 4x minus 6 minus x plus 7 is equal to 1 plus 3x plus 4. This is where the term grouping comes into play. Grouping is the process of bringing terms with similar unknowns together, or terms without unknowns, known as constants. So, if we refer to our paper, the purpose of this exercise is to ensure that the signs that are in front of particular terms stay with the terms. So I'm going to start the cutting, and what you want to do is basically get the box around the terms and the signs that are in front of them. So let me do a cutting here. So with each of the terms, we're going to make sure to include the sign in front of them. Now, if there's no sign in front of a term, it is safe to assume that there's an understood positive sign there. So I'll just put that there to make things more clear in front of the 1 on the right-hand side of the equation. Okay, so let's rearrange it as we saw it on the board. Let's get it in order. So 4x minus 6 minus x plus 7 is equal to positive 1 plus 3x plus 4. So now let's group our terms on both sides of the equal sign. So the first thing I would move to do is to move the x nearer to the 4x. Now, the concept that this exercise is trying to push is that the signs and their terms must stay together. So wherever this x goes, the minus sign that's in front of it has to follow. So if I were to bring the x closer to the 4x, then it would end up being 4x minus x. And this 6 would come closer to the 7. Now this 6 has a minus sign in front of it, therefore it must remain negative 6. So this side is arranged as much as it can be. Now the other side of the equation, let's see if there's any arranging necessary. Here we have two constants and a term with an unknown in it. In order to make our lives easier when simplifying this equation, what we could do is we could move the 4 closer to the 1. So we would move the 3x out of the way temporarily, ensuring that the sign in front of it stays there. Move the 4 across, and because there was a positive sign initially, this would become 1 plus 4. And we move our 3x to the other side. So in the end, our equation would look something like this. So our rearranged equation would read plus or positive 4x minus x minus 6 plus 7 is equal to positive 1 plus 4 plus 3x. Now that you've seen me use the hard paper and scissors to move the terms in my equation around, I would like you to do the same using these questions. You can think of a linear equation as a balanced state or an equilibrium state. To put this in a real-life context, think about a seesaw on a playground. If there's no influence from the wind and from external factors, the seesaw will remain in equilibrium or in a state of balance, with both ends of the structure being at the same level parallel to the ground. Now that we've established an equation as a balanced system, let us talk about keeping that balance. The balance of a linear equation can be maintained by a couple actions. The first of these that we're going to look at is by adding the same quantity or constants on both sides of the equation. So let me give you an example. But related to real life first, let's imagine that you were on a seesaw and you have a friend who weighs the same as you on the other end of that seesaw. If you were both sitting on the seesaw and somebody both gave you boxes that weighed the same amount, if those boxes of the same weight were added on both sides, the seesaw would not go out of equilibrium. It would remain in its balanced state. Both sides of the seesaw would remain level and parallel to the ground. So let's talk about addition to maintain equilibrium in a mathematical context. So we have the linear equation c minus 16 is equal to 4. If we wanted to add 16 to this side, then we also have to add 16 to the other side. So it will become c minus 16 plus 16 is equal to 4 plus 16. Now, the question may come about as to why that 16 was added, but that's a question to be answered at a later time. But just for now, the concept that we're trying to push and the main focus of this video is keeping the balance between the sides of an equation. Just know that whenever you do something to one side, like an addition, you must also add the same quantity or amount on the other side. So these two 16s would, in a sense, cancel each other out, and this would become c plus 0, and this side of our equation would be equal to 16 plus 4, which is 20. In the end, this would give us c is equal to 20. Another way we can maintain the balance of an equation is by subtracting. Now, just like with addition, we have to subtract the same amount or a constant on both sides of the equation. Now let's put this in another real life scenario. Imagine that you had a seesaw with 3 bags of cement on both sides. If you were to remove one of the bags from each side, you would still have a balanced seesaw. You would still have equilibrium in the system with both sides of the seesaw being parallel to the ground. So now let's put that in terms of math. Let's say we had the equation x plus 5 is equal to 6. Now if we wanted to get x alone, then we would have to subtract 5 on both sides. On the left-hand side of the equation, it would serve to make 5 minus 5 0. And on the right-hand side of the equation, we will be carrying out the same operation in subtracting the same quantity on both sides. So this will become x plus 0 is equal to 1, or in the end, x is equal to 1. So now that we've talked about maintaining balance in our equations, let's talk about what we really came to talk about, solving an equation. So the two processes that we've talked about so far, adding and subtracting to maintain balance, they both brought us to find the value of unknowns in the equation. And this is what solving an equation is all about. It's all about finding the value of the unknown or unknowns in an equation. And what this looks like, if you observe our examples, our mathematical examples for addition and subtraction, is having the unknown that you are looking for on a side for itself. So let's say that in this example, we were trying to solve for c. In the end, we see that our unknown c was by itself on one side, and we have a value for it on the other. Similarly with subtraction, we ended up with the unknown x on a side by itself, and it's the corresponding value for it on the other side. So as a math teacher, it is my firm belief that it's not enough to understand a concept through 1 or 2 examples. So what I am going to do now is I will demonstrate a few more examples in detail, and I would like you to pay close attention to how I'm carrying out and the presentation that I am using to show my work. So I'll now do 4 equations with you on the board. The first equation we'll be looking at is k plus 5 is equal to 21. In this equation, I'll be solving for k, and the concept that I'll be using is subtracting on both sides. So, remember I said that solving an equation means getting the unknown that we're looking for on a side by itself. So, what I'm going to do is I'm going to get k on a side for itself by subtracting 5 from this side. However, if I do that, I cannot not subtract 5 from the other side as well. So I'll proceed to keep the balance by subtracting 5 on the other side as well. So that will leave me with k is equal to 16, because 21 subtract 5 is 16. This is fairly simple, so let's look at a second example. Number 2. In this situation, we'll be solving for m, and the concept that I'll be using is addition on both sides. So we see that we have m in our equation, but it's not by itself. In order for us to solve for the unknown m, it will have to be on a side for itself. So in order to get it alone, I will add 10 on the left-hand side. This will, in a sense, get rid of the negative 10 that was there initially. And to keep the balance, to maintain the balance, I will add 10 on the right-hand side as well. I'll end up with m being equal to 11, because minus 10 plus 10 would work out to be 0. Now let's take a look at a third example. 2 plus f is equal to 3. Our objective in number 3 will be solving for f, and the concept that will be used here is subtraction on both sides. So the first step here will be to subtract 2 on the left-hand side to get f alone. So we'll end up with, this could be written like this, 2 minus 2 plus f is equal to 3. However, we must maintain the balance in our equation. Therefore, we will subtract the same amount that we subtracted on the left-hand side on the right-hand side as well. In the end, we will get that f is equal to 1. Now, the final example that I'm going to do is going to seem a bit more complicated than the other three, but please just try to follow and have an open mind when it comes to looking at these kinds of things. Number 4. 6 minus d is equal to 4. Now, our objective in number 4 is going to be to solve for d. However, pay close attention, that we're not looking to find negative d. We're looking to find d, positive d, or d only. So my first step will be to get positive d somewhere in our equation. In order to achieve that, I would have to, first of all, add d on this side to get rid of this minus d here, because that is not the objective of our solution here. We want to solve to find d, not minus d. So I will add d on this side to get rid of minus d, and I will maintain the balance by adding d on this side as well. In doing this, these two d's would cancel, and they would become 0. So I'd end up with 6 plus 0 is equal to 4 plus d. However, our job is not done, because this question requires us to solve for d. So to get d alone on the right-hand side, my next move will be to subtract 4 from the right-hand side. But to maintain the balance, this would mean that I also subtract 4 on the left-hand side. So this would end up being 6 minus 4 is equal to 0 plus d. So in the end, we would see that 2 is equal to d. However, this is not the only solution for number 4. Let us look at an alternative way to find the value of d, or to solve for d in the equation 6 minus d is equal to 4. So another step you could take is by first isolating or getting minus d alone. In order to do that, we'd have to get rid of the 6 on the left-hand side of the equation. Since this 6 has a positive value, what we would do is we would subtract 6 from this side, and to maintain the balance, we would also subtract a 6 on the right-hand side. This would leave us with minus d, because these terms here would cancel each other out in a sense, and we will be left with 4 minus 6, which is equal to negative 2. So we can now see by comparing the two sides of our equation that minus d is equal to minus 2. Therefore, which is represented by these 3 dots, therefore we can say that d is equal to 2. Because if negative d is negative 2, then we can infer, or we can conclude, that d would be equal to 2. So these are two solutions for the same question, and neither of them is wrong. So now that I've gone through some examples with you, I think you're ready to try some on your own. So on your screen should appear 5 practice questions that I want you to ensure to show all working for and to write all of your answers. I hope today's video was informative and interesting. As my math teacher said, math's sweet, math's nice, I could do the maths twice. Keep practicing, ladies and gentlemen. Take it easy, and I'll see you on the next episode of Spice Math.